Hey, welcome to our notes for parent graphs of trig functions. And first thing we need to do is fold up our notes, which they're a little different this time. So you're going to fold the sides of your paper in toward that center line and then crease the edges. And we're going to make a window shutter style graphic organizer. So with your scissors, you want to cut along the top edge here and just remove that top flap so that you can see the title of your notes. So we'll cut off that first flap on both sides. And then again, you can use your scissors to cut along these solid lines on the top, like this, so that when you fold open the cosine tab or the y equals sine of x tab, inside you'll see the graph and the features of that graph that go in with it. If you don't have a copy of the notes or a printer, feel free to make your own just by folding up a sheet of notebook paper and dividing it into 6 sections, one for each of our parent graphs, sine, cosine, tangent, and then their reciprocals will go across from them. So the reciprocal of sine is cosecant, reciprocal of cosine is secant, tangent reciprocal is cotangent, and then the quotient identity sine divided by cosine is tangent. So that's why we have them in that order going down the side edge. So we're going to start on the back of that foldable notes booklet, and you'll see a box for each of the vocabulary terms. If you want to pause the video, and the ones that are marked with a green star here, these are review from our very first unit of the year. So it's been a while. See if you can match the meaning with the term for those and write them in the back of your notes. Then the 3 blue starred terms, these are new for just trigonometric functions. We haven't encountered these before, but see if you can reason through what their meanings are and jot those down as well. And then when you're ready to check, you can resume the video. Okay, so let's go over the vocabulary together. We'll start with this one. All of the possible values of y for a function, also the output values, that would be the range of the function. Okay, then the x-intercepts or roots of a function, the value of x when y equals 0, those are called the zeros of the function. Okay, the maximum and minimum values of y on a graph, they can be relative or absolute. Those are extrema. We had absolute and relative extrema in Unit 1. Then regions of a graph that correspond to values of a function which are undefined, and we're representing them with a dashed line on the graph. Those would be asymptotes. They can be vertical, horizontal, or oblique. Then all of the allowable values for x in a function, the inputs, that would be the domain. So those are our review vocabulary from Unit 1 that we're going to apply here in Unit 6. Then repeats its value in regular intervals, creating a wave-like graph. That is a cyclic function or a periodic function. And trigonometric functions, because they're circular, we can go around the circle clockwise or counterclockwise forever in both clockwise and counterclockwise directions. And so that's what makes the cyclic or cycling wave-like graph. Okay, the horizontal length of one cycle of the graph that has a repeating pattern, the length of that cycle is called the period of the function. And then that leaves amplitude, which is defined as half the vertical distance between the absolute maximum and the absolute minimum, half the vertical distance between the extrema of a periodic function. And we call that the amplitude. So let's start by looking at the graph of the sine function. And on our unit circle, we're going to go ahead and grab some coordinates to sketch on the graph of the sine function. So when x is pi over 4, what is the y when we evaluate the sine of pi over 4? Pi over 4 is in quadrant 1 of the unit circle. Sine is the y coordinate. And so the sine of pi over 4 is square root of 2 over 2. Now that would be hard to find on the graph. So we're going to need a decimal approximation, which we get in the calculator, and that's approximately 0.7071. We'll just round that to 1 decimal place of accuracy for graphing purposes, so 0.7. Then at pi over 2, that's the positive y-axis. The sine is the y coordinate, and that's a 1. At 3 pi over 4, sine is still positive root 2 over 2, which is approximately 0.7. Then at pi, that's the negative x-axis. The sine, the y-coordinate is 0. At 5 pi over 4, now our sine is negative because we're in quadrant 3. So that's a negative square root of 2 over 2, or approximately negative 0.7. Then 3 pi over 2 is the negative y-axis, and that has a sine of negative 1. 7 pi over 4 is in quadrant 4, and that's a negative root 2 over 2, which is approximately negative 0.7. And then 2 pi brings us back around for a full revolution of our circle, where the sine is 0. So go ahead on your notes and graph those ordered pairs. So if we put a point here on the graph at pi over 4 in the x direction, and square root of 2 over 2 is 0.7, so it's going to be a little bit above half, and that'll be our point, pi over 4 root 2 over 2. Then at pi over 2, we're going all the way up to 1. Then at 3 pi over 4, we're coming back down to square root of 2 over 2. At pi, we're going to come to our first 0 because that's our x-intercept. Then 5 pi over 4, this is in the third quadrant now. We're at negative 0.7. At 3 pi over 2, we're down here at negative 1. Then 7 pi over 4, we come back up again to negative square root of 2 over 2. And then at 2 pi, we have another real 0. There's another x-intercept. And this is a cyclic function. It repeats this pattern. So this going backwards now, we come down to a minimum, then to a 0, up to a maximum, then back down to a 0. And I can follow this pattern in reverse now. So the sine of negative pi over 4 is going to be negative root 2 over 2. The sine of negative pi over 2, oh, whoops, too high. Negative pi over 2 is going to be negative 1. Then the sine of negative 3 pi over 4, negative root 2 over 2. Then back to our real 0 at negative pi. Then negative 5 pi over 4, we're up at positive root 2 over 2. Negative 3 pi over 2, we'll be back up at the maximum of positive 1. Then negative 7 pi over 4, we're coming back down now to positive root 2 over 2. And negative 2 pi, that's another full revolution around the circle, brings us back to 0. So if you imagine laying a piece of string or drawing a nice smooth curve through those points, that would be the shape of your sine curve. Okay, so if we wanted to describe the shape of this function, right, this is a wave. And its y-intercept is located at y equals 0. And x equals 0, so that's the origin, 0, 0. Then we have our first real 0 is going to be at 0. And there's repeating x-intercept every pi units, right? So here at 0, pi, 2 pi, there'd be another one at 3 pi, and so on. So we're going to say that the zeros are located at plus or minus pi times k, where k is an integer. And remember that E, the sideways E symbol, means element of, and then the set of integers is a Z, capital Z, with a double line in the center. So K is an element of the set of integers. Okay, the extrema, we have our first positive absolute maximum, right, is here at pi over 2 comma 1. So this is an absolute max of 1. And then we have another extrema when we reach the bottom of this valley. That would be our absolute min. Of negative 1. Okay, the domain is fully unbounded. There's no breaks, gaps, or holes. So this is a continuous function over its domain of all real numbers. And in interval notation, that's negative infinity to positive infinity. The range is fully bounded between the extrema. So we have a bracket at negative 1 and then a bracket at positive 1 to show that that's inclusive. The amplitude is half the distance between the extrema. So if our highest point is at 1 and our lowest point is at negative 1, that's 2 full units between the extrema, and the amplitude then is half that, which would be 1. The period is the length of one cycle before the pattern repeats. So we can see starting here at 0, we have a maximum, a minimum, and back to 0, and then that pattern would repeat. So the period of the parent graph of sine is 2 pi, one revolution around the circle. And the sine function has no asymptotes. Right? It's continuous over its domain. Okay, now we're going to take a look in Geogebra at this visualization of constructing the sine function. So if we grab this point, x comma y, and we're going to drag it around the circle in a counterclockwise direction, so looking at positive angles. Notice here my angle is increasing. Right here we're at 60 degrees, now we're at 90 degrees, and we've reached the highest point of pi over 2, the maximum, absolute maximum is 1. Now as we continue into quadrant 2, we can see, oops, there we go. got a glitch. We can see as the angle grows closer and closer to 180, now we're coming down and reaching 0 at half the circle, which is pi. Now in quadrant 3, the sign is negative, so we're under the x-axis, and as we approach negative 3 pi over 2, right there we find our absolute minimum. And now in quadrant 4, we're coming back around to 1 full revolution, which is back at 0 for 2 pi. So this is the curve for our parent graph of the sine function.